angles, and this was the worksheet I handed out yesterday. I know I don't have any extra copies, so some of you guys don't have it, but this was the worksheet, so I just pulled it up here so you can at least see what we were working with, and I'll go ahead and go through the answers as well. So first off, just talking about angles in general, right? We measure angles in degrees, and there's complementary and supplementary angles. So to get the complementary angles, that means they add up to what? They add up to 90, right? So you just do 90, and so it would be, this one, the complementary would be 57 degrees. And then for supplementary, they have to add up to 180, so you just take it away from 180, and that comes out to be, what's that, 147?
No, 157. Maybe
I think, try that again. I'm pretty sure, because 157 would get you up to 190, I'm pretty sure.
Oh, maybe that's fine.
Yeah.
I think I might have been 190.
Yeah. Okay, so it's always 180 for supplementary. And then same thing here. So for 82.6, to get the complementary angle, you would just do 90 minus 82.6. That would be 7.4 degrees. And then to get the supplementary angle, you would take 180 minus 82.6, and that would be something like 97.4 degrees. Yeah? What do you say? Questions on those ones? It's just the definition of complementary and supplementary. Yeah. It says two angles. This one's more of a word problem like we were doing before. Two angles are supplementary. What does that mean they add up to? They got to add up to 180. The larger angle is 36 more than the smaller, so we're going to set this up in an equation. So you have one angle and then another angle, which is 36 degrees more. And if you add up the two angles, since they're supplementary, they should add up to 180. And then you're going to solve this equation. So that's 2x plus 36. Oh, I just realized. Oh, I am recording. Nice. Equals 180 when you combine your like terms. Subtract 36 from both sides. What do you get? 2x equals 144, which means x would have to be divided by 2. 72. Then the bigger one would have to be 108. What do you think? Questions about the setup or the solving? Which one?
X plus
36.
what?
Yeah.
No, the last one. X plus something
This is
equals
30.
108.
This is 36.
Okay.
Sorry, it doesn't look like a 38. For some reason, I don't know why. I just
can't
don't.
read your-
I don't write threes very well. I don't know why.
I thought it was a 7.
I have pretty bad writing. I'll go slower and try to be better. The smaller I write, the worse it gets. But I wanted to leave the whole thing in the frame, so. Anyways. Yeah, but the reason I'm solving it is because, see, this is like angle number 1. This is like angle number 2. So we solved for angle number 1 with the equation x equals 72. And then I went back and got the other one by adding 36 to that because that's the relationship of the two. And you can check that you got the right answers because they should add up to 180 because they're supplementary if they do.
What you did, you said something, you said that in
Oh, well then just forget what I just said. But our equation solved for that value. Right.
Okay, so that's
But I also asked you for
the
that.
first one.
Yeah.
Right. Okay. Oh, for both angles.
Yeah,
Oh, okay.
since I wanted both angles, you have to go back and figure out what the other one. There's two ways to get the other angle. First off, since you know they're supplementary, you could just do 180 minus that. That would give you this. But we also know from the beginning when we set it up that the other angle is 36 more than the one we solved for. So. Okay. What about angles and triangles? What do they have to add up to? All the angles in a triangle have to add up to? Also 180? I don't have any extras of this one. Sorry. And so then it would be, well, we have a 28 degree angle and 111 degree angle, and then there should be some third angle that we don't know, but they should add up to 180. So then you just figure out, well, we've already taken up basically, what is that, 139. So then to solve for it, what do? You just take it away, right? And so you should come up with, what's that, 41 degrees? Basically, you just say, well, I've already taken up this many degrees, and then so what's left over is just whatever's left over from 180. Okay. Questions on that one? Not too bad. Then we did similar triangles. So if you look at, these are supposed to be similar triangles, so we can set up an equation to help us solve for the missing side length. We want to solve for the side length x. So we're trying to find this value. So we just match sides basically, right? So x is associated, is the same as what on the other triangle? X is to 9 the way that, say, 10 is to 15. So you set up a proportional equation, and you say, okay, so x is to 9 the way that 10 is to 15. And then in proportional equations, you cross multiply to solve them. So the equation becomes 15x, 10 times 9 is 90. And then you can just divide both sides by 15. And so it looks like x is going to be 6. You could try your calculator. But 90 divided by 15, I believe, is 6. Okay. So set up the proportional equation, cross multiply. All right. Any questions on that one? Not too bad. All right. Then these ones were just with Pythagorean theorem. The thing with Pythagorean theorems is you just have to make sure that you know whether or not you are looking for a hypotenuse or you're looking for a side length. And the hypotenuse is always the longer side in a right triangle, right? So the Pythagorean theorem is a squared plus b squared equals c squared, where the c is the hypotenuse, it's the long length. So in this one, what are we missing on the first one? A, B, or C? We're missing a C. We're missing a hypotenuse. So we can use the equation, 16 squared plus 12 squared equals C squared. The C is what we don't know. Then you're just going to add these. So 16 squared, I think, is 256. 12 squared is 144. When you combine those, they add up to, I believe, 400. So how do you finish these Pythagorean theorem ones off? How do you get rid of that square? You got to take the square root of both sides. So the last step when you're solving Pythagorean theorem is always taking the square root of both sides. This one comes out really nicely. Happens to be a whole number. Okay. That one's not too bad. Questions about that one?
So the hypotenuse is always C?
Yeah, and it's the long side. Yeah. Mm-hmm. And it's C. It's always C in the formula. So what happens then is that if you have the hypotenuse though, then you're going to be missing a different side. So like you could call this A, and then like B is the unknown side. So 8 squared plus B squared we don't know is equal to 17 squared. So if you have the hypotenuse, you just know the value on the other side of the equation. But that's okay, we can figure that out. So 64 plus B squared, 17 squared is 289? Is that true? I'm not sure actually what 17 squared is. I think it's 289. Is that right?
Yeah.
Okay. All right, and then what would you do to solve this? Well, you would subtract, right? So you'd just be left with B squared equals 289 minus 64. What's that take down? 225. And then the square root of both sides. So it looks like B would be 15. 225 happens to have a perfect square root. So the difference here is that if you have the two side lengths, you add them together and then take the square root. If you're missing a side length but you have a hypotenuse, you subtract the square root of each other and then you take the square root. Okay, what do you think on that
Why
one?
do you bother setting up the square root for b squared if you never do anything to it?
Oh, it just comes from the problem. It just comes from the step before it, because when I subtracted 64 from both sides, I was left with a b squared on the left hand side and a 225 on the right hand side. But I'm just going to turn around and get rid of it by taking the square root. Okay. Other questions on that one? Those ones were nice because they had whole number values, because the number you took the square root of ended up being a nice whole number, a perfect square. But if you don't have that situation, I did say, ooh, look at that, that was cool. It says up here, I don't know what happened, but it says round to the nearest tenth. And so like these ones, we're going to run into a situation where we're going to have to round. So this one we have side squared, we're missing the hypotenuse. 6 squared and 6 squared, so that's 36 plus 36. And then so those add up to 72. But when you go to take the square root, 72 doesn't have a square root. So if you plug that in your calculator, what do you get if you do like root 72? What's it give you?
Like 8.48.
So it's like 8.48 dot dot dot.
Yeah.
So then if you're going to round that to the nearest tenth, what would that be? 8.5.
So then that's only the approximation.
Yeah, so that little squiggly equal sign, it's an approximately symbol, and it's saying basically that this answer has been rounded. It's not the exact answer. Okay? Questions on that one? All right. And then the other one is like the problem above it. You're going to set it up because you have the hypotenuse, so it's kind of like a squared plus 5 squared, because you don't know a, and then is equal to 17 squared. Well, 5 squared is 25. 17 squared we figured out before was 289. So you subtract 25 from both sides. And then you have a squared equals, well, 289 minus 25, that's what, 264. And then if you take the square root of both sides, well, what is the square root of 264? It's something. 16.248 dot dot dot.
Yeah.
And then you're going to round to the nearest tenth, so that would be 16.2. Be the answer on that one. Yeah. What do you say? Questions on any of those geometry triangle applications?
So you're always rounding.
My problem specifically asked you for that. So just pay attention to the directions. What you'll normally see is, and my things covered it up, but normally what they'll normally, and I think my quizzes say the same thing. It says round to the nearest tenth as necessary. What that means is it means that rounding may not be necessary. So if your answer comes out to a whole number, just leave it. But if your answer comes out to some messy decimal, then you round and do it to the tenths. But pay attention, because on a quiz it could say hundredths, or on a test it could say hundredths. Typically it's tenths. That's usually, one decimal place is usually enough, but not always. Yeah. Any other questions about any of those? All right, so then those are the basics of triangles. Angles add up to 180. We got the Pythagorean theorem for right triangles, right? Those little square inside, that means it's a 90-degree angle. The Pythagorean theorem only works for right triangles, though. So it doesn't work for any other type of triangle. So it has to have a 90-degree angle in it for the Pythagorean theorem to apply. Yeah? Okay, the last thing that we cover in this class, so this is it, is it covers a little bit about working with areas of shapes. So, and we've already done some areas, actually, area problems. So the idea is, so for the common shapes, the ones we're going to see is going to be triangles, squares, and trapezoids. But really, it's just an application of applying the formulas. So a square, you already know the area. If you have a square, say length by width, what's the area for a square? Yeah, no, well, for the area, it's just length times width. Okay?
Are you going to provide the formulas? Or do I need to like?
No, so you need to know the formula for a triangle and square. The trapezoid's a weird one. You don't have to memorize that one, but you should know the formula for the area of a rectangle. That should be probably memorized. And then also for a triangle. So triangles we define by their base and their height. And so the area of a triangle, a base times the height would give you the square, and a triangle is half a square. So the area of a triangle is 1/2 times the base times the height. So these two right here, you need to know these ones. You know.
And what about
well, and really, actually,
simple interest formula and the what like?
There's also I'm going to add here before we get into trapezoids. No, you don't need to memorize the interest formula.
Okay.
I'll show you. I'll show you right now. These are the ones that you need to memorize. Okay. So for a triangle, the area is 1/2 base times height. For a square, the area is length times width. Then we had the circle stuff that we covered back in a while ago. I don't remember, back in October probably. So for circles, remember the area is pi r squared, and the circumference is pi times the diameter, right? Where the radius is the half length and the diameter is the whole length. These four formulas you should memorize. You should know these ones. And I'm guessing you probably do know these ones, at least you kind of would remember, but these ones won't be provided. So if you get a question on the final about the area of a triangle or a square or a circle or the circumference of a circle, the formula will not be provided. It's expected that you know those four. If it's something less common, like the interest formula or like trapezoids, then the formula will be given to you in the problem. All right. Okay. So these are the most common formulas we have in geometry. I have some practice problems here that you can work with. There is the only one that we do in this class that you don't have to memorize would be a trapezoid, not a trapezoid. Let's do this. I'm just going to let you write that, and I'm just going to erase it and write the trapezoid formulas. So has everyone got those written down? Okay. So then, those are the so then for the trapezoid. So trapezoids are like they're quadrilaterals with two parallel sides, but the other two are not parallel necessarily. And in a trapezoid, you have two bases, base 1 and base 2, and then you have a height. And the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So, yeah, you don't have to memorize that one. But that's the area of a trapezoid. Trapezoids are you encounter them a little less common. But they're in the section to be covered, so I have some examples where you practice calculating the areas of a trapezoid. But that formula would be supplied to you on a test if there happens to be a trapezoid problem on the final. Okay. But as far as like using the formulas, it's pretty much I mean, we already have some practice. We use formulas with the interest. We used formulas back when we talked about circles. And so I just have some practice problems here for you to look at using these formulas, and that's pretty much it. That's all that the class covers. And that's as far as we go in geometry. We do all the triangle stuff, the Pythagorean Theorem, and then these few little shapes with the area we look at, and that's about it. And perimeter, of course, what's the perimeter of a shape? What's the perimeter? What's the perimeter? Yeah, right? So it's the distance around the outside. And that's always, right? It's like, you just add up all the sides. So there is no formula really for perimeter for shapes. you don't really need one. It's just the perimeter is the distance around the outside. So if it's a triangle, you just add up the 3 sides. If it's a square, you add up 4 sides. You know, if it's an octagon, you add up 8 sides. So it's just the sum of all the sides. So I'm just going to pass these out and let you guys give these a shot. Some of them might be a little more challenging than others using the formula. I made a mistake. If you look at the Trapezoid formula, I forgot the H on there. So you can write that in. But I did write them at the top of the worksheet. And this is it. So tomorrow, tonight, make sure you're taking a look at the practice test. Then come tomorrow with any questions. I won't be doing any new material. I don't have any more worksheets to hand out for, but I'll be here to answer. We'll go over any problems you want from the practice final, and then that's technically the last day of class. But on next Monday, so a week from today, I'll come in during class time. So we talked about that already. So I'll be here next Monday if you want to come in and ask questions or go over any stuff. But that's optional. It's not actually a class day. So.
I have to go take my mom to the doctor.
All right. So basically, that's it. So come in tomorrow if you have questions or you want to go over some final exam stuff. Come in on Monday if you have questions or you want to go over some final exam stuff. And then after that, I'll just see you at the final on Thursday. Next Thursday, obviously. No, tomorrow's just questions, whatever you want. Yeah, it's not. I have nothing else to show you.